So, y equals 3x plus 4 is an equation. Specifically speaking, it is a linear equation. Because it is of the form y equals mx plus b, which is the slope-intercept form of a line. Now, I could, and we all know, if I pick a value of y, I end up getting, one solution for x. But when we have an inequality, you would end up getting more answers. And I'll explain what that is when I do, or show you how to do it in the graph. So what you see here is a linear equation, but if I change that equal sign to a greater than or equal to, less than, or less than or equal to, then we have linear inequalities. So equal sign, equation. If we don't have an equal sign, if we have greater than or equal to, less than or equal to, then we have inequalities. Specifically here, we have linear inequality. So what we're going to do now is to graph a bunch of them, get used to the inequalities. Then I will explain some operations using inequalities. Now, we want to graph x greater than 4. Key things to note. All we have here is one variable, and that variable is on the x-axis. So x greater than 4 would simply lie on the x-axis, and you have to pay attention to the sign. If it has an equal sign, then we put a closed dot at 4. If there is no equal sign, then we put an open dot at 4. And in our case, there is no equal sign, so I'm going to put an open dot. But maybe I'll use a brighter color. And x could be any value bigger than 4. So all of those would satisfy the inequality. So all of those are possible values for x. And naturally, you have infinite possibilities. Now, let's say we have y less than or equal to 2. Now, notice there is only one variable, and in this case, that is the y variable. So we are on the y-axis. And notice that there is an equal sign. So we start at 2. And we put a closed dot. And everything below that too will be an answer for y. So these are all possible values for y. And y has infinite possibilities as well. So y equals 1 is a solution. Y equals -5 will satisfy that condition. Y equals -4 will satisfy the condition, and so on. So this is in tail. Now, what if I combine them together? So what do I mean by combining them together? So far, we looked at x by itself, y by itself. Now we want to put them together. So let's say I'm going to move, we will pick 3x plus 4. From up here, I'm going to pick y greater than 3x plus 4. You can say that that inequality has both y as well as x. So I'm going to move the variables to one side and the x's to the other, numbers to the other. So you will have y minus 3x greater than 4. So now you have both variables, and that should satisfy this inequality. In order to do that via graph, so we're going to graph, we have to understand that this 3x plus 4 is a line. Once we recognize that 3x plus 4 is a line, the next question to ask is, should we put a dotted line or a solid line? Just like we had an open dot or a closed dot, if there is an equal sign present, then we would draw a solid line. If the equal sign is absent, then we would draw a dotted line. So first off, we need to sketch the line. That's quite important. So let's see if we can sketch it. Since it's an easy equation, I don't want to use the calculator, but I will show you how to use the calculator to graph, excuse me, inequalities. So we have to select some values. So I'm going to select -1, 0, and +1. We only need 2 points to draw a line. We know this. And y is equal to 3x plus 4. So when x is equal to -1, y is 3 times -1 plus 4, which would give us 4 minus 3. So we get 1. When x is 0, we have 3 times 0 plus 4. We end up getting 4. When x is 1, we have 3 times 1 plus 4. We end up getting 7. So -1 gives us +1. 0 gives us 4. And 1 will give us 7. Going to connect the dots, and you can see that we have a greater than sign. So I'm going to use a dotted line because there is no equal sign. Let's see if I can draw this properly. Close. I'll just make the dot bigger. Now, even though I put dots there, I put the dots just to indicate that the points lie there, the points that we created. But do keep in mind, since it is less than, the solution that would satisfy the given inequality will not include those points. So I will just erase, oops. Oh, the struggle is real. Okay. So -1, 1. Okay, so it's better to avoid confusion to simply put open dots. This way, when you look at the graph, you don't get confused. But when you do MyLab Plus or on an exam, it may or may not have an open dot, but do keep in mind that the solution cannot lie on that line because we cannot include the line as part of the solution. So what is the solution then? The solution would be the entire area, any number that falls here will be a solution for the inequality that we have. So what do I mean by that? So again, we would have infinite possibilities. So I can pick a point here, that is a solution. I can pick one there, that is a solution. I can pick one there, that is a solution. One there, that is a solution. But if I picked exactly on the line, it's not a solution because it is lying directly on the line. So all of these are solutions. But the red dot is not a solution. So the region that we drew right here is a solution for y less than 3x plus 4. The one in yellow. I'll draw in teal. That would be the solution for y greater than 3x plus 4. That was a mistake that I made. I thought we are talking about less than, but we are actually talking about a greater than equation. And this should be a negative also. No, doesn't have to be. Okay. So we just draw the line and then we come up with less than or greater than, and you can see from the picture which side is greater than and which side is less than. And right in the middle, it's a dotted line. So any point that lies on that line, dotted line, is not a solution. So you do have to note, you may say, well, here with x greater than 4, we just drew it on an axis, but could it be something else? Well, it could be, and it could be an entire region. For instance, if I use the terminology of a function for any value of x or for any value of y, when I say x is less than or less than 2, I would end up getting a whole bunch of possibilities. But we can also draw a region like I drew here. When I demonstrated this, I only did it on an axis so that you don't get confused. But I can draw something like this. A very good example would be a simple line. So consider y equal to 2. We all know that that is a line. And specifically, it is a solid line. So if I change the equal sign to less than or equal to 2, I can simply draw it on the axis like I did earlier. But since this is a function in a functional sense, what I have here is a line that goes through 2. And everything below that would be a solution for y, if we express it as a function of x. Because as I move x, no matter what value of x I have, every single value that is less than or equal to 2 will be an answer for y. So by all means, I could sketch it this way. I didn't want to do it at the beginning because I don't want to confuse you guys. But here, all of those would be a solution because y does not depend on x. So for any value of x, we will have a corresponding y value and it will satisfy this inequality. And that entire region would be a solution satisfying less than or equal to. And notice we put a solid line because of equal sign. Okay, so here we have the inequality y greater than or equal to 4x plus 2. We always start with the line 4x plus 2. So that is the slope-intercept form that we have. So we know the y-intercept is 2, so that point is easy. And if I plug in 1 for x, I will get 6. 4 plus 2. If I plug in, excuse me, put it at the wrong place. Oh, my bad. When I plug in 0, I will get 2. When I plug in negative 1, I will get 0 because negative 4, positive 2 would get 0. I will get negative 2. So it's right over here. And I have to connect the dots. Now keep in mind, we only need 2 points to create a line, but I'm just drawing extra so that I can, computing extra ones so that I can draw the line properly. the more dots you have, the better it would be. But it's not necessary. Now that we have the line is y equals 4x plus 2, and it is solid because we have an equal sign, and we now have to sketch the region. Since it is greater than, all of these are possible values that would satisfy the inequality. So all of those are accepted, or numbers that will satisfy this inequality, including the points on the line, because we have a greater than or equal to sign. So here is a case very similar to what we did, but suppose I have y minus 2x less than or equal to 1. You may look at that and say, well, there is y, there is x, but how do we graph this? It's not that difficult at all. You just have to move all the x's and numbers to one side, keep y on the other side. So the very first step would be y minus 2x less than or equal to 1, followed by y. Move that 2x to the other side, or simply add 2x on both sides. So y less than or equal to 2x plus 1. And now you would know the line that you have to sketch, and that line is 2x plus 1. So the intercept is 1. I can plug in -1. If I plug in -1 for x, I'll get -2 plus 1. That's -1. I'm putting closed dots because there is an equal sign. And if I put in x is equal to 1, I would get 3. So it's right there. And I'm just going to draw the solid line. Hopefully it goes through. Okay. And not perfect, but it's close enough. Now we go back to the inequality sign. It is less than. So we draw the line, which is y equals 2x plus 1, which is right here. Now we have to account for everything less than 2x plus 1. So everything below would be a solution. So we have to graph minus y plus 3x less than or equal to 2. So move all the x's and the numbers to one side, that is the key. So minus y is less than or equal to 2. Positive 3x moves to the other side, becomes negative 3x. But you should notice that there is that negative sign. We have to get rid of that negative sign. So I'm going to multiply both sides by -1. So y negative of 2 minus 3x. I intentionally left a space there because we need to know that the sign would flip if we multiply an inequality by a negative. So what we had as y less than or equal to now becomes greater than or equal to. the sign flips because we multiplied by -1. So that would mean y is greater than or equal to, distribute the negative. -1 times 2 is -2. Negative times -3x is positive 3x. So y is greater than or equal to 3x minus 2. So that is the function or the linear function that corresponds to the line that we're about to draw. And the sign is greater than or equal to. We are going to draw a solid line because because we have an equal sign. So the intercept is easy because it is -2. We can see it in the slope-intercept form. When I plug in x is equal to 1, I would get 3 minus 2, which would be 1. When I plug in 2, I'll have 6 minus 2, I get 4. And that's my line drawn approximately. It's not very exact. The sign now is greater than, so we have to use the upper region for the solution. So anything above the line will be a solution, including those points that are on the line, because we have a greater than or equal to sign. So this is the flipping the sign is the tricky part in this particular problem. And I've seen students forget to flip the sign. Okay, so we have -2x less than minus y plus 3, which is the same as saying minus y plus 3 is greater than -2x. I'm writing it that way because most of us are familiar with seeing y on the left-hand side. That is the only reason why I wrote the original inequality in that form, because of familiarity. Most of us would like to see y on the left-hand side. So now I'm going to move the number, which is 3, to the other side. We have -2 minus 3. I have to multiply by -1 on both sides. So -1 times y is positive y. Since I'm multiplying by a negative sign, the sign has to flip. -1 times -2x is positive 2x. -1 times -3 is positive 3. So the equation that we have is 2x, the linear function that we have is 2x plus 3. The line that we're about to draw is a dotted line because there isn't an equal sign in the inequality. So let me put an open dot at 3, because that is the y-intercept. If I plug in 1 for x, I would get 5. If I plug in -1 for x, I'll have 3 minus 2, I'll get 1. All I have to do now is connect it with dotted lines. Or dotted line, I mean, there's only one. Close enough. It's not very exact, but as long as you get the point. So everything below the line would be a solution, or points that would satisfy the given inequality. So all of that will work for us. So that is how you would graph the given inequality. And the key thing here is, once again, flipping the sign, because the y carries a negative sign. One of the things that we want to know when we do systems of inequalities, which would be next, is to understand the operation and is intersection, and typically we do inverted U. So anytime you say inverted U, it means and that simply means an intersection. So we would have two inequalities, and we want to find something that is common to both. So our objective is to find the region common to both. So we're going to do this a lot when I get to 4.52. I'm just going to do a simple example so that you understand what I mean by intersection. So graph a simple case, x greater than 3 and y less than 2. So once again, we're going to look at it from the perspective of a function. So x greater than 3, y less than 2, both of the lines have to be dotted lines. So I'm going to draw a dotted line here. And I'm going to draw a dot, oh, excuse me, that is x greater than 3. So dotted line there. And y less than 2. So you should recall that when we try to draw the line for a minute, you have to realize that the line that corresponds to x greater than 3 is x equal to 3. And the line that corresponds to y less than 2 is y equal to 2. So y equal to 2 is that line. So y equals 2, x equals 3. Now, x has to be bigger than 3, so all of those would be a solution. And y, of course, these would be included as well, but nothing on the line. And y has to be less than 2. And the region that is common to both will be the solution. And that in our case, oh no, it's okay. And that in our case would be this part. So this is x greater than 3 and y less than 2. So the numbers that fall there would satisfy the given inequality. So when we get to 4.5 systems of inequalities, this is what we need. We need to find the region that is common to two different inequalities, and that region is what we call a solution region. So before we get to that, I'll quickly show how to graph an inequality using your calculator. This will come handy when we do 4.5. Or come in handy. Okay, so going to start y equals, and I'm going to start with the line, let's say 3x plus 4. And I'm going to go over to the left by pressing the left arrow. I'm going to go to the far left, and you can see that the cursor is under that line, a diagonal line. The first time I press enter, it's wanting to know if I want to draw a solid line. Press enter, the shaded triangle is pointing upward. In other words, I am looking for the region bigger than 3x plus 4. So if I hit enter one more time, it's showing the region below 3x plus 4. So when I move the arrow back, the region is naturally below, and that's my selection. So if I graph that, so everything below the line, 3x plus 4 is sketched. And let me pick another line, let's say 4x plus 5 or 6. And this time I want to, 4x plus 6, and move the arrow and enter. Going to shade the area above that line. So move the right arrow to set the region setting, now graph, and that would be everything above the line. So this is how you draw or shade regions above and below a line using your calculator.